Welcome to a very important part of this conference. This is important as always, but in this period of time, because of the current situation, this item topic, global collaborations, is much more important, and especially for the European Union area. There's an assumption that there will be some kind of an energy crisis in this winter. So we have the panelists from all over the world. In the beginning, I want to check if I call their names right. First, I want to call you Mr. Papp. Is it okay?
Yes, it's okay. I'm here. Thank you very much.
And I want to call you Mr. Buchner. Is it okay?
Alfred is fine. Thank you.
Alfred. Okay. Okay.
Yes.
I will change it. Mr. Alfred. Okay. And Mr. Gülck.
Perfect.
Okay. And Mr. Morales.
Better Rodriguez is here.
This is Rodriguez. Okay, Mr. Rodriguez. I will do it. Okay. So I want to start with you, Mr. Rodriguez. As your name is listed in the left side, I will go following in this direction. As we know, you are the head of the Cogeneration organization in Spain. I want to start with you, with your assumptions about the current situation and how Spain will overcome this situation.
Okay, first of all, thank you very much to our colleagues from Cogen and to the sponsors for the invitation to share with you all. I think you were much right. It's time to share and to find solutions because we are in a very difficult situations in terms of crisis. And we think that here in Spain, and we are in the upfront of the changes and the market reforms and package of legislations that we all need to manage the situation in the next month and for the future. Okay, so I think I will go when you tell me to a 5-7 minutes presentation in which I will tell you the situation, what happened here with this experiments of new mechanism, interventions on markets, how we should do things and what things we have already learned in Spain about intervention of markets, especially the Iberian mechanisms that is now on the table if this is going to be up leveled to an EU level. And it's a matter of adjusting regulation because markets should give good results to all consumers, especially to the countries, to the people, to the industry. So whenever you want, I'll start your presentation. I don't know if you want to make first a common position about the situation. The situation is difficult, but definitely with CHP, you are in a much better position to attend the high requirements of the crisis we are in. Okay, do you want me to go ahead with the presentation? Okay. Let's try to have a 5 minutes overview of what CHP is in Spain's present conditions and the keys for the future. In Spain, with CHP, we produce 11% of national electricity generation. We consume around 20% of natural gas consumption of the country, which is a lot. You think it's more than all the buildings, housings, and the commercials It's around 40% of our industrial gas consumption. And the most important thing is that CHP in Spain, when we talk about CHP, we talk about industry. 90% of CHP is related to industry, manufacturing industries. We are talking about 600 sites with around 1,000 facilities or groups of CHPs. When it comes into Europe, we are, let's say, in the group that has more share, more production of CHP, just after Germany and Italy, and very close to Netherlands and Poland. On the right, you see that in the past we had a softer support from the EU climate and energy policies. They are being somehow, in terms of energy efficiency policies and CHP, we have a softer support than renewables. And that is a situation that have incidents or consequences in the evolution in the last 10 years. You can see here, we started in Spain 30 years ago with CHP. It was very good for the country. It allowed us to construct all the gas grids. At that moment, we have not got grids. It allowed us a lot to have, at the moment, in the Iberian Peninsula, 7 LNG, liquid natural regasification plants, which is 30% of the capacity of Europe. And you see that in the last decade, we were steady with a likely tendency to drop, okay? Natural gas, we switched. In the past, we had much coal, fuel, all kinds of fuel. CHP is agnostic in terms of fuel, but nowadays, our reference for the present is natural gas, and for the future, renewable gases, especially hydrogen, as we are going to have a look. It is more or less the mix with just a small part of the total installed power in Spain. I think that in Spain at this moment, 50% of electricity production comes from renewables, photovoltaic, eolic, thermal, solar, 20% nuclear, and let's say 25% gas. That is a combination of CHP and conventional and combined cycles. Okay. So let's say that 50% we produce this 11%, the national generation, but 50% of that is self-consumed by their own industries. Okay, and the surplus, it goes nearby the local areas. We stand, it's different in other countries. They have mass district heating or other kinds. CHP is a tailor-made solution. So let's say that 20% of Spanish industrial GDP is produced with CHP, which plays an important role in heat-intensive industrial sectors. These sectors are common almost in all around the world: paper, chemical, petrochemical. In Spain, the first industrial sector using CHP is food and beverage, because it's our main industry. No? So you have more. After that, we have an understanding power installed in tiles and ceramics, refineries, textile, with board, automotive, everything. But if you, with food, paper, and chemicals, let's say it's half of the total production in the factories. You have the characterization of the plants in terms of technology and size. Let's say that we have size varying from small scale CHP up to 50 megawatts. We have to combine the cycles, also in Spain that they operate partly at CHP, but they are not in our regime. Let's say the average size 6 megawatts. It's not much if you think about this 5,000 megawatts of installed CHP, and in terms of conventional combined cycles, we have 5 times 25,000 megawatts. Okay. Just a view on regulation. CHP requires thorough regulation and coordinated evolution with the energy and climate policies, and especially in this moment, a very fast adaptation to the crisis circumstances. You can see there what is the evolution in the last 20 years, just part of that, to see how complex is year after year to be adapting regulation and CHP to achieve optimum results. Let's say just the idea is that today, or the remuneration, the scheme, the economical scheme we have since the last 7 years in Spain is based on two principles. First, you have to give to investment a reasonable profitability. That is more or less 7% at the moment. As soon as it goes higher, it will adjust. And the other thing you have to guarantee is that the costs of the operations of the plants, they are covered, and also that they allow CHP to compete in the market with other technologies. That is the two principles. Here you can, just in this figure, I will not go in depth, but we sell electricity, we receive the price of the market, and then we have a surplus. One is investment. As soon as you recover your investment in 7 years, in 8 years, whenever, this investment retribution goes to zero. Let's say CapEx, and then OpEx, operational expenditures, that is, it should cover the costs. And in order to determine the cost, we review the fuel prices every 6 months. That has been one of the problems with the crisis that I'm going to show you right now. This period of 6 months is not is too large when the market has too much volatility. Okay, the same principles. Spain is in the upfront. I think we are in a good position and tradition to be in that situation, and that implies that in some occasions you are taking risks. We issued this year several packages of regulations. Yesterday, the last one, especially for CHP, in terms of to guarantee the energy supply, full switching, fastering energy transition, crisis management, protection of consumers, solidarity. We are producing 22% of the electricity of Portugal, exporting to Morocco, exporting to France. Solidarity is very important. But what happened to us, as I'm going to show you in the last 6 months, is that a slowness in adapting national regulation for CHP to electricity market intervention, and the volatility of the gas market price has placed our plants in a very difficult situation this summer. Until, well, happy, we just got yesterday in place a new royal decree, and it will help to solve this situation. This is what happened. You see there in the graph that compared the production last year and this year. Regulated CHP generation dropped 70%. That means that we stopped 2 out of 3 plants of CHPs this summer. Okay? And the reason is that our government, together with the European Union, we made an intervention in the electricity market that it was implemented the 15th of June, the so-called Iberian market exception, and we also call it gas cap mechanism. Right? And this mechanism covered conventional combined cycles, gas turbines, plants, and also coal, but they exclude CHP. So that is intervention of market, exclusion, together with fast developing and boosting of natural gas prices, as we can see on the chart on the right. And not fast tracking of the review of the CHP fuel cost that we have in the remuneration led to an unprecedented fast drop in CHP production. Things that in terms conventional support after this intervention to conventional electricity, almost double the support that we have in our regime. Okay. We are happy to say that we are on the way to recover our production. On just beginning of September, our president announced to include these measures to recover CHP. Also, there are many other measures in places for biomass, services for industry, boost renewables permitting, and an incoming revision of our CHP remuneration. Okay? But we learned some lessons. Our Iberian mechanism is working, but markets, as I said before, market reforms must drive results to consumers, to industries, to countries. The European Commission took good note of the results. We have been much in contact with them, and the result of this Iberian mechanism in order to improve challenges. In example, the CHP attention. Okay? Some ideas. As soon as you do new packages of regulation, you have to guarantee a level playing field for CHP to compete in the market. Flexibility is the key. We are going to have now the possibility to every month choose between different schemes. Flexibility is the key to adapt to evolution of the market. Quickness. You need to have fast processing of all the regulation. Also, we learned that we have an opportunity in Spain with our infrastructures in natural gas and our market with gas. In fact, the problem right now is industries that are linked to TTF, that is a reference that should be quitted and especially capped at euro level because it's not efficient. And accelerating energy transition. I will tell you a little bit more right now. All the situation is accelerating energy transition. Perspective. The crisis is accelerating changes. It's an opportunity to the evolution. In terms of RES development, renewables development, and also CHP investments. Investments is the blood for industry. And industry has a commitment with investment, with the future of the industries in a country. And CHP is a perfect partner for this energy transition in industry. Some key elements. In fact, we are going to increase energy efficiency results for the plants in terms of required regulation. We have this concept that is very high efficiency. That means a primary energy savings higher than 15%. Let's remember that the European regulation is 10%. So we are going to increase efficiency requirements in 50%. Decarbonization is still the key. As I said, David was very right when he's saying about that future comes from renewable gases and hydrogen. And here in Spain, we have lots of synergies with projects, ongoing projects with hydrogen generation linked to industrialization CHP. An industry close to these hydrogen projects and with a CHP, which we are already ready, technically ready for hydrogen, it's a win-win for hydrogen industry and the country. Hybridization.
Yes. I have to interrupt. I'm sorry. As you know, there is a time limit, and there is a problem that before our panel, this is the 5th panel, before our panel, there are some delays. That is why if we want the 6th panel to start earlier, we have to cut it short. I'm sorry for this one. And there are another 3 panelists. So I would like to ask you to finish your presentation in 2 minutes, please.
Okay, I'll do it in one. Sorry, you're right. I'm doing 12 minutes. Just to finish, hybridization, all our industries, they are doing hybridization at industrial sites, fuel diversification, and we are installing photovoltaics at the industry, hydraulic, and other. We have already effective regulation in place to do that. Integration with RES. Here in Spain, in some moments, we have 70–80% of the production coming from wind and photovoltaic. So CHP needs to boost the flexibility, and that comes in terms of digitalization and flexible management. We are developing also proximity selling to establish local electricity markets and management optimization. Some industries, they have much interest, especially with the process of investments for outsourcing, to find partners and third-party long-term agreements to do all this evolution in which energy transition comes with it. I leave up to you. We are going to undertake, we already have regulation, the proposal to undertake a process of investments in 1,200 megawatts of CHP for the next 3 years. We have been working, and as soon as the situation allows, these actions will be performed, and we will pass from all the difficulties to these new challenges with new investments in CHP. Thank you very much, and sorry for the extension.
Thank you very much, Mr. Rodriguez. So I would like to continue with the next panelist to use our time as much effective as possible. Mr. Papp, we are ready for your presentation. Mr. Papp, we cannot hear you right now. Mr. Papp, can you open your mic, please? Yes.
Right now, hopefully you hear me, and I hope I succeed to share my screen as well. Or no?
We can hear you and we can see your desktop, so please.
Okay,
start.
I'll try to. Okay, so thank you very much for the invitation to let me the chance to introduce the Hungarian situation right now. First of all, Cogen Hungary is a member of Cogen Europe, same way, and Cogen Spain as well. So we have a lot of national member in Cogen Europe, and we try to utilize our common knowledge to each other. As far as I know, there is a lot of Turkish investment in Hungary. So let me briefly show in what is the situation right now in Hungary. In Hungary, we accepted a year ago, or a little bit more than a year ago, strategy. But in the meantime, the situation changed a lot, but the key element is still remain. In a long term, we would like to provide the Hungarian energy consumers based on nuclear basis. So we have a 2,000 megawatt nuclear plant, and we started to build a new one. When this old one will be decommissioned, we still would like to hold this basis. If you are talking about gas-based generation, which is the gray color, we still remain until 2014. So if you are talking about the cogeneration and the gas facilities, we would like to hold as far as the future as we can. If you are talking about the renewable revolution, we would like to be a late action mover. So we have a late action scenario that the target for 2013, we would like to have the green target of 90%, of course, take into consideration our nuclear plant, and the carbon-free generation we would like to reach at 2015. The question is, but it will be the question of the future, that in which way we will reach this more than 12 megawatt photovoltaic plants, and in which way we will adapt it to the grid, but it's the question of the future. And as you can see, the wind power, it was popular. Yes?
We cannot see the changes you make in your computer. So it is still in the opening page of this presentation.
It's interesting, but on the other hand, in such a way.
Now we can see it. Yeah.
Yeah, probably it's not work, the slideshow. So in this case, you can see again, if you are talking about the Hungarian energy mix in the strategy, mostly solar, basic nuclear and gas-based, and a small other part of renewable. We are very proud that we were able to influence a little bit the strategy. So in the new energy strategy, the gas-based generation in the future probably will be subsidized and will be applied in a much wider range. And it will be probably take to consideration some subsidy scheme or bonus scheme in Hungary as well, because the Hungarian government and the strategy maker realized that take to consideration the cogeneration advantages, first and foremost the security supply, and the decentralized energy generation. It is a part of the strategy. But what is the situation in nowadays? You can see the Hungarian energy mix, first and foremost consumption. If you can see the purple parts, it's import. So it means in Hungary, we are very depending on the others' energy generation because we import a lot. And this trend is continues from 2008 right now. So it's more and more import we have in Hungary. If we are talking about the generation, then you can see this yellow color, it's new solar plants, the basic as well, as you can see in the built-up capacity, the continuously operating nuclear power plant, and the coal, we decided to switch the coal-fired generation in Hungary until 2013, but take into consideration the present gas crisis. Probably this plant lifetime will be extended. If you are talking about the cogeneration, in this slide, you can see that the share, the utilization is a little bit better than in the past, but we still have a lot to do with this. And what is very influence our grids, you can see this very big growth in the solar generation. In the next slide, you can see the built-in capacities, and you can realize the same what already mean that in the last couple of years, from all the solar capacity grew up until more than 3,000 megawatt, take to consideration the small power plants in the households as well. And what is the what cost for the grid is? You can see below right now it's a September daily curve of the generation. You can see below the nuclear power plant running continuously, then the coal-fired power plant, then comes the gas, and this huge part is right now is solar. So it's a very significant growth, and we have to follow it with the grid development. After the short presentation of the total Hungarian situation, or the Hungarian next generation, what about the cogeneration inside? You can see the development of the cogeneration in CHPs in Hungary. We have a very nice years in the early 2000 until 2010. Until 2010, we had a feed-in tariff for cogeneration, and from one day to the other, it was cancelled from the policy. And this is the reason you can see a picture. This is a bartender. It's a flare bartender. His job is very hard because on one hand, he has to have an acrobatic, has to be present to the audience, a lot of nice acrobatic things. But at the end of the day, it was asked from him or her that, okay, come on, I would like to taste your cocktail, it has to be nice. So in the same shoes, we feel as Cogeneration companies in Hungary that from 2010, the regulatory always changed year by year, and it's influenced a lot the capacities, the running plants, and the still plants in live, the economic possibilities. But fortunately, from 2015, I think it's Hungarian unique. We started to build up this virtual power plant, and all of these small CHPs connected to one big partners and start to develop their services and sell it, this balancing energy and other system regulation products to the Hungarian TSO. So right now, what is the reason behind of the growth from 2015 is that most of the CHPs via this virtual power plant, and of course the big plants alone, are taken part from the Hungarian balancing energy market and earn via most of the money via this way. So generally, right now, the utilization a little bit less of the CHP plants than was in the 2000 until 2000 and 2010. But financial point of view, the situation is better, and on the other hand, still we have no new investments in CHPs in the past years, but at least the reconstructions and major overhauls has already done, so it's still alive. But what does it mean? And one very important, comparing, for instance, Spain. In Hungary, we have at 10% of the generation shares as co-generators, and right now we reach again the 15%. Comparing in EU level is, in install capacity point of view, of course, Hungary is a small market, a small country, but generally proportionally, we are in the middle, so we have still task to develop it, but we are in a good position in an average of in Europe. A couple of words, because a lot of colleagues already discussed the present crisis, what's happened in Hungary. Take into consideration the lot of solar generation, the balancing energy requests of the Hungarian system highly increased the demand. And if one of the most important markets, as far as I told, the CHP generation, if you are talking about the other generation point of view, comparing the other gas plants or the coal plants, the increase of the CO2 prices and the gas prices caused a better practice for CHPs. So right now in Hungary is I think, a good place for the CHP generators. And unfortunately, take into consideration the new gas prices or the very increased gas prices comparing to last year's, almost 10 times higher, the district heating generation or the generation price in Hungary. But it's very important because district heating is the most important heat market for CHPs. So hopefully in the next heating season, the district heating companies will be able to pay for this big money for the heat to the producers. And a couple of words, I think I'm right now at the end of the time. Some words about the future. I have seen from the colleagues in the cogeneration companies a lot of nice view for the future. I try to a little bit talking about the contradictions or the risk as well. In Hungary, and I think as well as in Europe, the biggest value of the CHP is the good efficiency and the flexibility. So mostly the CHPs follow the requirements and sold balancing energy to the TSOs and the DSOs. It could be a best market for them, but in the last couple of years, new players appeared on this field of the business. A lot of renewables started to change their production curves, and I tried to and started to involve in the balancing energy market. And other new players, there is the energy communities, of course, more and more active consumers, and that are not just the consumers or household consumers, but the big industrial companies is able to control their energy demand. And of course, there is new players, the aggregators, based on the new laws in Europe. And the other competitor could be the energy storage, as well as the PV market was dramatically developed the last couple of years, and the panel prices dramatically decreased. I think in the same will be appeared by the battery market as well. If you take into consideration the present situation and the gas dependence of the Russian gas, as well, the CHP is a big advantage because of the high efficiency. This is the most effective way to use it for electricity and heat generation as well. So in this way, we can decrease the dependency, not just in Hungary, but I think all over Europe. If you are talking about the other basis or other legs of the CHPs, the heat market, it is a new competition as well, because there is a lot of trends as far as in the, first and foremost, we can see in the EU legislation in Brussels that the lobby of the heat pumps and the electric heating go forward and forward. So it's a new competitor in the heat market of the CHPs. And last but not least, a lot of different countries is subsidy scheme or some premium scheme for the CHPs. In Hungary, unfortunately not. Right now we have some extra taxes for energy generation, and hopefully at the end of the day, if we go forward the carbon neutralization, our government, as well as I show in the strategy, we realized that to be competitive in the European market, we need some subsidy scheme as well, because on the other hand, all of the players in the European market start to connect. So right now, I think until end of 2014, based on different kind of projects, this Picasso and Mari projects, everybody in Europe will join a common market in Europe, and hopefully it carry itself a big competition as well, or more competition than before. And just set an example, in Hungary, when we opened our electricity stock exchange to the first in Eastern Europe, then to the XBID, then the volume or the trading volume of the stock exchange was increased 10 times higher. So all of the markets open carry itself more competition. So I'm still optimistic, take into consideration the present situation and the future chances in Hungary, and hopefully in all over Europe, CHP will play a key role to reach the climate changes actions. Take into consideration that in a fuel point of view, the biofuels and the hydrogen could be the future instead of the natural gas. Thank you very much for your attention.
Thank you very much, Mr. Papp. The last part of your presentation, possibilities and risks. I think most of the items apply not only for Hungary, but also for the whole Europe area. So,
hopefully it will be.
Yeah. So we will continue with Mr. Gülck, and he's from Germany. Am I right, Mr. Gülck?
Yes, sir. Okay. Greetings from Germany.
Yeah, and Germany is, as far as I know, the biggest power producer, the biggest Cogen power producer, and also the biggest power consumption value in all Europe. So this crisis will directly affect your country, and there are some rumors that the industry will be heavily affected by the Ukraine war. So we are listening to your presentation. Thank you.
Yeah, thank you very much for the kind introduction, and that I have the opportunity to have this presentation at this audience here. Today, I want to tell you a short story. I know that I have only 10 minutes available about the German biogas market.
Mr. Gülck, no, you have 15 minutes.
I have, even
yeah.
better. So it's because I was pointing out the biogas market, because as you said, we are struggling a little bit with the natural gas situation and shortages. But before I start, I want to introduce shortly, of course, my person. My name is Michael Gülck. I'm working for Chevron. Chevron is working with a brand named Texaco in Europe, and our partner for the Turkish area is Petrol Ofisi. And we are very technical oriented. That means I'm working for the CHP market since over 35 years now. And I'm a former Jenbacher employee. I worked for 7 years for Jenbacher. I worked for Caterpillar also for 7 years. And I work now since 6 years for Chevron. I'm the CHP expert for Chevron Europe. And today I want to tell the stories about some technical problems we generate with the energy changes we have in the market. As I said, I want to point out the biogas segment in Germany. The biogas market and the CHP market in general is the biggest market in whole Europe. We have around 42,000 CHP units running in Germany, starting from 1 kilowatt electrical output up to 26 megawatt output. Around 10,000 of those are from the biogas side. That means the biogas market has made a very nice travel through the last 30 years. Here you can see the numbers accumulated for the biogas sites we have in Germany, and up to today, I said again, nearly 10,000 biogas sites. You can see everything starts around 2000, 2002. In 2002, the German government was releasing a subsidy law, a supporting law called Renewable Energy Law, to push the renewable energies, especially these biogas sites. And what I point out, because I was hearing all these political situations and problems we have, I want to point out how important it is that a country government is supporting such a technology. Here we have the biogas sites, new biogas sites per year. And here you can see on 2011 to 2012, there was a change in the, I want to say, subsidy situation coming from the government. That means the situation becomes a little bit more complicated to supply electrical power to the grid. And furthermore, the subsidies, the support money was shortened in this time. And you can see immediately the new numbers of CHPs was falling down. And in Germany, we have today a green government, to be honest. And the situation, I'm not sure what I have to say about this, because as a Chevron employee, I cannot make any political statement. But I can talk about facts. And one of the facts is that we have definitely a problem with new biogas sites in Germany, because this renewable energy law was founded 20 years ago and guaranteed support money for each produced kilowatt hour for 20 years. That means the first old renewable energy power plants, they're not running out of support. That means we expect to see in the coming years definitely a minus for new biogas sites, and this under the roof of the green government. Renewable energy and special CHP is important. Here we have some numbers about turnovers and also jobs we are generating in this biogas segment. We are generating over 9 or nearly 10 billion euros, but much more important, we have 40,000 workers in these areas. And these workers, they are buying a truck, they're buying a van and whatever. That means the biogas segment, including the CHP segment, is a player and it's from economic interest. Unfortunately, I don't want to make any statement, and I was thinking about it, to talk about the natural gas situation and natural gas CHP in Germany. And but I must say it as clear as today with the natural gas shortage, with the Ukraine war, I have no clue what happens in the next 2 years around natural gas CHPs. But I want to tell you a story. Also a little bit, I want to change the angle of view, and I want to keep focus on the technical figures we see with this new situation and also with the energy transition we see. That means that we get more and more renewable energies into the mains, to the grid. At first, I want to start what is so special about the gas engine CHPs, and because we are facing, and we are at Texaco, we are a producer for gas engine oils and also for gas engine coolants, what is also a very important topic. And we are facing some new technical problems. And one is very special about gas engines. Gas engine is the most stressed engine application. No truck application, no other diesel application has such a stress like a gas engine CHP, because we have a very fancy parameter on CHPs. This is working hours. It means a well-designed 24/7 operation engine is running over 8,000 working hours per year, maybe 8,300 working hours. The year has only 8,700 working hours. That means some CHPs are only shut down for maintenance, and then they get back to the grid and always running at full load with highest efficiency. And this is creating very unique problems on gas engines. What is interesting is in Europe, we have around over 90 CHP manufacturers. And these 90 CHP manufacturers, they provide or produce over 1,200 different kind of applications. Biogas application, natural gas application, hot, cold, whatever. So there are many, many things open. We start now also to think about hydrogen. What means start to think about? Many units are still in operation, running with hydrogen. And we see this hydrogen movement or development for every CHP manufacturer. Because when you want to sell a natural gas application, for example, in Germany, it has to carry a sign H2 ready. This is a must. The funny thing is, for this H2 ready, there is no specification behind it. It's the same situation with this bio certification on food. There is no specific, there's no meaning behind it. The German government is now creating a regulation. What does H2 ready really means? Here we see the technology trends for gas engines. Of course, I will not highlight everything here. I just want to highlight, of course, the hydrogen developments, because hydrogen is facing the engine with new problems, because the methane number, that means the knocking resistance of hydrogen, is 0. And a standard gas engine is designed for a methane number, the knocking resistance of the gas, for 70 or 80, depending on the engine manufacturer or application. That means to design a gas engine running on hydrogen, this is a challenge, really a challenge, and it will take several years to make really hydrogen run reliable with constant and high efficiency and full load operation for a longer period of time. That will take a lot of developments, especially for the gas engine oil. Special gas engine oils are required to meet the hydrogen demands. Everybody is talking about emissions. We have new regulations in the European Union, the MCP directive. MCP stands for medium combustion power plants. It was founded in 2015 with new emission levels, and each European member has to bring this to a European law. The final goal is that the new settings should be implemented also for existing power plants up to 2030. All CHP sites who deliver today must still meet the new requirements, and we are talking about very, very low NOx emissions, 100 milligrams per cubic meter. This is very low. That means this is something what the engine itself cannot generate inside the combustion chamber. We need exhaust treatment. That means all future CHP and also retrofit for the existing CHP will be retrofitted with or equipped with an SCR catalyst. What needs AdBlue? AdBlue is something what you have in your modern diesel car, and it costs money. And when you run a 1 megawatt unit, and depending on the application, then we are talking about an AdBlue consumption between 50 up to 30 liters per hour. These are additional costs, and it's very hard to argue this to the CHP operators. Then we see, and this is also funny, we see more and more in Germany on natural gas applications and coming back of the stoichiometric Lambda 1 application. Lambda 1 is a little bit old-fashioned. Some of them are equipped with a catalyst. Most of them are not equipped with a turbocharger. Some of them have a turbocharger, Waukesha applications, for example. And why it becomes so sexy, the electrical efficiency is a little bit lower, but we have more heat on the thermal side, more thermal power. And the benefit is we can use a three-way catalyst on the Lambda 1 versions, and we don't need to add to bring in AdBlue. And this is very cost efficient. That means on many applications in the future, we will see a coming back of Lambda 1 applications. But anyway, every CHP manufacturer, every OEM is working on this to increase the efficiency. And here's an interesting graphic coming from Jenbacher. When I start working on CHP, the electrical efficiency was around 33% of electrical efficiency. And then we have, I call it stairway of evolution. That means every step a new efficiency increase takes needs or brings new challenges to the engine oil. And here we have the development for engine oils coming from Texaco under the brand name HDUX. That means for every new development, efficiency increase, we see new challenges on the engine oil, and new developments was requested. Because I want to highlight that engine oil, for example, is technology. It's really technology and has to face the new upcoming demands. New upcoming demands are, for example, we have new market requirements. That means the sources for the energy, electrical energy production is changing. Here I have from 2015, week number 4, the electrical power production for Germany. 78% comes from coal and nuclear power. And this has changed in the meanwhile. Here we have week number 4 this year. And you can see, and I think I don't have to explain this deeply in this audience, there is a change. We get more and more of these renewable energies Here in this area, we have wind. The yellow ones are solar power, but in week number 4, of course, we have less solar power. That means the grid becomes more and more, what shall I say, unstable. And that means this unstable brings more and more the requirements for flex mode operation, or what we call for CHP peak shaving mode. Because the operation is changing for CHPs, the new demands. It means from 24/7 operation up to 8,000 over 8,000 working hours, only 100 up to 150 starts per year, 100% load, and oil temperatures at start between 45 and 60 degrees Celsius in the oil pan. Here are the new requirements for flex mode operation. We only have 500 up to 2,000 working hours per year. The number of starts are increasing to 1,000 up to 2,500 starts per year. Every start for a big gas engine is really hard to care, because at very low speed during starts, the bearings and the oil film in bearings cannot do their job. That means every start is worn out, so to say, on bearings. Then we are run with power between 50 up to 100% load, not on full load operation anymore. And then we have a problem majorly on biogas sites, that we have very low oil temperatures during start. Because around 71% of the CHP in flex mode operations in Germany are installed in a container. And when we have winter time, the floor in the container becomes quite cold, and we have the cold is climbing up into the oil pan, and then we have very low temperatures. That means we are running into problems with the engine oil viscosity. Even when the engine stood still, then also the engine oil is under attack, so to say, from condensated water, oxygen, and whatever. That means even when the engine stood still, the engine oil is under stress. Yeah, I have a very nice graphic to demonstrate what happens in flex operation. Unfortunately, I don't have the time to explain you this in detail, but please keep your focus on the blue barrels. In the past, it happens that that the engine was running 24/7 at full load. And today we see that the engine is only running 1 hour or 2 hours, 3 hours per day. During weekends, it could happen that the CHP unit stood still because the German industrial is not working. That means there is no electrical power demand. Then it stood still during the whole weekend. And this change on operation and what we call flex mode or peak shaving or peaker or whatever you name it is a big change and a challenge also to the engine oil. Promotion at least. Here we have the Texaco HDUCs, gas engine oil products. And
I have to interrupt. We are about 19 minutes right now, please.
Yeah, I'm still at the end because my question was, thank you for listening, and I'm open for questions. And I know that I drift a little bit away from your standard agenda, but I think to have a little bit view on the technical side is also important. Thank you very much for listening.
Thank you very much for the detailed info, especially for the gas engines, lubricants. In Turkey, we don't have that much weather, but in your country and also in the northern countries, that this will be a problem, and also this will open a gate to new technological developments for the lubricants working much better in low temperatures, because there's a demand on this because of the current working principle of the CHP. Thank you very much. So our last panelist for this panel, Mr. Alfred, I will not rush you for the time because we are the 5th panel in this in this series, and I know there's another panel after ours, but please keep it in time and use your time wisely. Thank you very much.
Yeah, absolutely. Thank you, and thank you for inviting us for this conference. It's a very interesting conference. I enjoyed the whole day of these sessions. The good thing is I heard the name of 2G several times, so I'm quite happy with it. 2G, for those who do not know us, we are specialized on cogeneration. We are a German gas engine manufacturer, and we are one of the few companies which are able to already operate since a couple of years on 100% of hydrogen. So we started relatively early with the development. This is our company. We are in North Germany, on the border to Netherlands, and we were founded in 1995. If you recall the slide from before, this was just at the beginning of the biogas boom. So that was basically an earlier starter advantage. The area where our factory is a farming area. We grew relatively fast, and 2007 we became since 2007 we are stock listed. We have 850 employees, 11 international subsidiaries, and supplied already 8,000 CHPs into 50 countries. So quite a solid track record of quality, I would say. What is special with 2G is we have a relatively large output range. We cover from 20 to 20 kilowatts to 4.5 megawatts. And we see ourselves as a solution provider, as not only selling the gas engines, we really have a life cycle solution approach where we want to be engaged from the design stage up to the end of the life of the engine, doing also the after-sales service on all our products. What is special with us as well is we focused on, as a gas engine manufacturer, relatively early on efficiency improvements. So here you see the results. Our focus was rather different to Yambacher, what we heard before, to the small output, which was kind of neglected by the big OEM. So we focused on the development of engines from 20 kilowatt or under 550 kilowatts. Here just the example of a 200 kilowatt engine from 37.4% electric efficiency, we improved up to close to 42% of efficiency. And also, of course, the output is always relevant. So we also increased the output to 250 kilowatts for this engine. Another important factor is reliability, of course. Efficiency and reliability go hand in hand, in our opinion, or in our experience, and fuel flexibility is also key. So we have the flexibility with our products to operate on natural gas, biogas, or a mixture of both, propane, flare gas, and recently also we added hydrogen capability, 100% hydrogen, no problem for us. And we have here the product portfolio. I think I skipped this. This is what you are most familiar. This is your typical CHP customer segments. We have installation on all of them. I decided to add one slide after hearing Mr. Gülck's good presentation. Absolutely right. Maintenance is key, and the engine needs to be ready exactly when you need it. So nowadays, it's absolutely essential for any engine operation to really have a digital solution. We go a little bit further. We have a predictive maintenance, so we have a kind of cloud system where data are collected from the plants, and based on the trend of the engines, it will calculate when a part should be changed or when a trouble is coming up, whether you should change that part before the weekend or after the weekend. So this is quite essential, and we utilize this also throughout the globe. So also our plants in Japan, our plants in Australia are using those systems, and that's how we keep the units running even when Germany is sleeping. I think that's nowadays digital. Without digital solution, there's no way to go ahead. This is a little bit of a view on why hydrogen, why we focus on hydrogen. The market, I think I don't go into the details. You heard it already from so many different countries. So electricity demand is growing in Germany also tremendously, as is expected to grow. At the same time, there will be a ramp down, a fuel switch away from nuclear and coal. Nobody knows how fast the trend goes, but definitely there will be such a trend. And renewable energy, of course, will increase. You see on the 2050, as currently we are at the 40% in Germany. So this is still manageable, but when you look at the 80% in 2050, you see the green peaks. This is where you have overproduction, and the red areas where you still see the red is underproduction, which means that's when solar and wind are not operating. And that's exactly where we see the storage opportunity of hydrogen. Energy storage energy needs to be stored, and hydrogen is the perfect slide. I just showed because it's pretty similar what like before. If you take out the coal and the nuclear, that's how a typical German day in 2021 would look like. So we do not expect since February 2022 that the government would do that all with natural gas. So there needs to be alternative, and we believe that hydrogen is one of them. Another important factor for hydrogen, in our view, is emissions. We spoke before. Everywhere it gets more drastic and more strict. You have with CHP relative good emission values, but when you look at the hydrogen, you see that hydrogen basically have no NOx and very low CO2. And that's why we believe this also will be the future. This is not through a catalyst. This is really out of the combustion principle. That's how we see the future grid, and that's where we see some like before. I think David at the beginning mentioned Hungary, where these systems are already tested, where in principle through an electrolysis process, hydrogen is produced, goes into the grid as after methanization, or goes directly to power plants as pure hydrogen. This is something where out of competing technologies like wind and solar, suddenly you have partners, you have partnerships. So for us, they are customers, and I do believe that these partnerships will get stronger in the future. That's how we do it, how we operate it. This is the traditional way. As mentioned before, it's quite tough to burn hydrogen because it has is quite explosive, let's say. And that's how we do it. As we basically, it's like a diesel principle. You suck in air and then you inject hydrogen, and that's how we, in principle, can also upgrade our existing natural gas or biogas plants with a very simple gas injection kit, where we, in principle, then have the advantage that the customer, whenever he receives hydrogen, cost-effective hydrogen, then he can upgrade to the upgrade at one of the maintenance intervals. The good thing with hydrogen is that from the operational characteristics, they are pretty similar than running on natural gas. Our 1 megawatt engine on natural gas runs at 750 kilowatts of hydrogen gas. So this is very, I would say, reliable. Full load operation is possible. 50% as a same conditions you can run on island mode. Gas blending is possible. So it's for us already after, I would say, 7 years of development. Around 7 years of development. It's quite commercialized, and we have plenty of references, as you can see here. I think altogether around 20, many of them already in commercial operation. These are these systems. You can have a look on it. If you look at the output, that's the one which was also mentioned in Dubai. There is a Kirkwall airport in UK which also is the first 100% hydrogen plant in the UK. Quite proud we are with the Japanese. As you know, Japan is a challenging market. So we have Toyota as a customer at the main factory. Their engine is prepared for 40% hydrogen, but can be easily upgraded to 100% hydrogen whenever they are ready. And the goal, of course, for Toyota and many other customers is carbon reduction of their facilities. And we are, I would say, on the best way to be part of that. And we are quite proud to have a lot of partnerships, also in the gas engine business. Like before, we heard Yanmar, so that's a good global partnership we have, and Siemens, so this and many more. So I do believe that, as I mentioned, I see hydrogen also as kind of the way for global partnerships. From rivalry, you become partners, and here you see the advantage of CHP systems. I think we are exactly in the target triangle of the energy industry. Efficiency, sustainability, and reliability of the system is given with CHP. So I do believe that this is the future, and I would be very happy if also in Turkey or throughout Eurasia that many more of these power plants could follow. So that's it from my side. This is, if you have questions, you can contact me. And I hope it was interesting.
Mr. Alfred, I have one question. I'm not sure if a moderator should ask it, but you have informed us about this reference in Toyota City, and they are using only 40% hydrogen and the rest in conventional methods. What is the main reason for this one?
Yeah, it's very often it's the availability of gas. If hydrogen, as let's say one big advantage of our system of gas engines in general, I think, is that we don't need the 99.999% hydrogen, so we can work also with impure hydrogen gas. So we are operational relatively easy. But don't forget, as the cost of hydrogen is still too expensive. So it's in my opinion simply a commercial decision. This is a pilot plant. As I would expect to have, most of the installations which we have is to be honest, we're also running on gray hydrogen, but these are plants where it's more about energy efficiency. So this seminar, I think, is more mainly about the green hydrogen for the future, and that's why I focused on these references.
Okay, thank you very much. Thank you very much. So I want to thank for all of our
yes.
Thank you for all our panelists for using the time wisely and introducing very different aspects of this very big topic. So all of the four attendees are focused on other sides, but in all together they are coming to the same point that we are in a point of crisis, but there are some solutions to overcome this. I want to thank you all again. Thank you very much, and I will pass the word to Mr. Yavuz. Thank you.
Çok
thank you also.
Bey. Çok sağ olun moderasyonunuz için. Thank you very much for all you attended from Spain, from Hungary, and from Germany. Thanks a lot, and have a nice day.
Yeah. Thank you so much. Thank you so much.
Thank you so much for the invitation.